Alright, Lucas. So yeah, here's the plan. I've really gone to town cleaning up the brass control strip here where all the pots and stuff connect. Because also your original coupling caps connect ground there. So this lead, this ground wire that comes to this eyelet isn't just a piece of bus wire, it's actually the lead from this old cap. Goes all the way down through the eyelet and connects to ground on the chassis. So when I redo the coupling caps, which I have now determined that we have to do, I will do the same with the new ones. So you'll see the sprags in there, much smaller of course, but the leads are long enough to get to the control strip. So a lot of people just leave this wire and then try to ram 4 new, because there's 2 resistors here, plus the 2 cap leads, plus the old ground wire into an eyelet here, and it gets real bulky and shitty solder connection. So that's often a spot of failure after a recap. So I'm gonna get these ones in there all the way to the control strip, just like they did with this dual section cap in the first place. So there'll be 2 of these tied together, 1 leg going all the way to ground. And I can show you here, this is the one for the first gain stage. I pulled it up through the eyelet from ground here to get the big chassis iron out to heat that up. And lifted the positive leg, which you really have to isolate it from the circuit to get a proper measurement on the cap tester. So I can show you now with the cap totally removed from the circuit electrically. Positive, negative, Sencor value is 37 microfarads, so way high. It's supposed to be 25. And leakage 120, 110, 100. So for a cap of this size, that's not allowable leakage in this position. So I'll check it out when I measure the brand new sprag that I'm going to put in there instead. So 28, that's within our 10%, and leakage 0.0000. That's what we need. So yeah, the brown turds, the toilet papers, will be coming home to you in a plastic bag for vintage charm. You can put them on your mantelpiece, and we'll have perfectly functioning Sprague atoms in there, which are the choice of the experts as replacements, and they'll also last for 25 more years like your new filter caps will. Okay, so that looks pretty good. So we got our new Sprague atoms in there using their leads to get all the way to the ground on the control strip, and I used the massive iron to get a beautiful solder joint on that control strip. Solid as a rock. So I can do the same thing, next position. I already removed this cap. I've got it on the tester right now actually, and its value 36 again, so it drifted really high. And leakage, yeah, leaky. Leak check on the V4 cathode bypass cap. Oh, leaky. And there's the new cathode bypass caps. All soldered straight to the brass control strip. It's a beautiful thing. Okay, so with the wall voltage at 118, our heaters are a little high at 6.44. So this might be a good candidate. So all, you know, plate voltages and stuff are a little hot across the board too. It's all stock, and it was designed to, you know, run on 115. So I'm not surprised things are a bit high, but this could be a candidate for using one of those brown boxes or something. If you feel like it's too gnarly ever, you could hook that up. So yeah, 6.5 on the heaters, which is supposed to be 6.3, too hot. And you know, some of the plate voltages here are on the hot side too, you know, 190 and stuff on the preamp tubes, 230 on the 6v6s. So that would all go back to sort of exactly stock if you had a variac or a brown box where you're setting this thing to always get 115 from the wall, because then it's going to be just perfect. So let's look at V1's plate here. That's all right. DC. Yeah, 185, you know, not far off. V1B, 182, just a little high. V2, 190. V2B, 189. You know, those are supposed to be 170. I checked these plate resistors, and they are exactly 100K, so it's not that they've drifted low or something. So just voltages in general are a little hot because 60 years ago, the voltage was a little less hot coming out of the wall. So everything's basically stock and perfect now. The new cathode bypass caps are in, and we're getting great readings on the cathodes here. 1.4, 1. Oh, sorry, that's the reverb set. Yeah, 1.3, 1.4. You know, tiniest bit high, but again, everything is going to come down if we do a brown box or variac. You know, I'm talking about to make it exactly perfect. It's great as is, so nothing to worry about. It's just like, ooh, if you really wanted 1965 perfection, you'd feed it 1965 wall voltage. A lot of times when the, you know, DC voltages in the amp are high and people want to bring them down, they can just add a slightly higher value resistor in the doghouse, those two resistors that are in there, but that won't bring your heater voltage down. And most people would rather just use a variac or a brown box to get the voltage lower, but it will also bring their heaters down. So you gotta just find that perfect balance. But I think maybe I'll set up a variac, feed this thing a little lower wall voltage, and see if everything becomes exactly perfect. But yeah, man, looking really good. I cleaned it up a bunch. There is some kind of corrosion around the where the brass control strip used to, or still connects. I did clean them really good before soldering the new connections to the cathode bypass caps, and those are so solidly in there, more solidly than they were when they left the vendor factory. All right, more soon. Okay, and this is how we're gonna clean the shorting jacks on your Deluxe here. So you see this little tab, this is from the hot, and this little tab shunts the input to ground when there's no cable connected. And sometimes dirt and corrosion builds up in between, so when there's nothing inserted into this plug, you still get a bit of noise and stuff because it's not getting fully grounded. So we put a plug in there, and we get a little paper soaked in deox it, wedge it between the shunting and the tip, pull the plug out, and give it a little pull. And we just do that for each one. A little bit of dirt coming off. Yeah. Nice and clean now. Okay, so we're just gonna take some measurements for leakage around the board. On the actual board itself, sometimes because there's a fair bit of contamination here, so voltage can leak from one eyelet to another just via the board. I've cleaned it up a bit, so you can see here like plate voltage 186, cool. And then when we check for voltage on the ground of our new cathode bypass caps, we get 0, 0, 0, that's great. And then if we just measure on the board itself in various locations, stray 30 millivolts, that's nothing. Here, stray 20, that's nothing. Stray 30, that's nothing. This eyelet is pretty close to some action, so 20. And then when we get right around where this transformer was replaced, this is your reverb transformer wiring, and some flux and stuff got left on the board. Watch this, right between these two eyelets. 200 millivolts, more, going up like half a volt sometimes, depending where I touch. 1 volt. So we got to clean this part of the board up. This is your V4 coupling cap, so that's like your highest gain, highest impedance part of this circuit that sends your final signal out to the phase inverter. So this, if I clean the board up in here, should get even cleaner, not cleaner, but less noise and buzz and hum in the signal path. So let's clean it up and measure after. Okay, so clean that area of the board up nicely with alcohol, isopropyl, and let it dry. And we're powered back up, so plate voltage on the one here, 182. And if we check some places on the board, 0. There's our sort of 30 that we were seeing before. I'm just gonna give this tip a quick clean here. So yeah, we're zeroed out, 30 millivolts, 50 millivolts, no problem. 45, 50, no problem. Here's where we were seeing half a volt before. Now 50, 60 millivolts, just like everywhere else. So if I find any more hot spots on the board, I'll spot clean them like I did over there. I don't really want to rip this whole board apart and isopropyl the whole thing, but if I find any more bad spots, I will, especially in such a sensitive area as V4B. Anyway, I think we got it. Yeah, 30, 40. Other side, good. Yeah, little by little. So most of these pots are pretty good. That's a reasonable amount of hiss for vibrato channel. Noisy pot on the reverb. Let's just fix that right now. Trim's fine. Reverb. Let's just give them a little clean. Perfect. Okay, so I'm getting down to cleaning and tightening the pots behind the knobs. The pot, this connection is how the pots get ground, so it must be clean and tight. And I figured while I'm in behind, I would clean the front panel up a bit too, so you can see how here, not cleaned, here, cleaned, not cleaned. So I'll make it all look nice. I'm not gonna go crazy, but while I've got the pots off, I like to get in behind there and make the panel look nice too. Yeah, so there's our pots all off. And yeah, you can see it pretty loose. So it's a very easy quarter turn, which is likely all they need. Oh, that one's more like half a turn. And then we clean them up all nice. Just about lost you there. You okay? Oh yeah. And you don't use anything fancy here because the lettering, the stencil work on here comes off if you use any kind of cleaners on it or anything like isopropyl or WD-40 or anything crazy like that. It's not corrosion we're getting off, it's just muck, grime. So this is just a moistened t-shirt. Wouldn't even call it wet. I'm basically avoiding the lettering anyways. Yeah, that looks nice. Get these knobs back on. Got them all lined up here. You can kind of feel where the old indent was. Once I have them all looking right, I'll tighten a little further so they don't go anywhere. Now the knobs themselves, you can't even wipe with a wet cloth or this paint will come off. So you just leave them. If you really want, you can get in the grooves with a little brush, but this isn't a museum piece. I mean, it could be. I mean, the chassis has seen a lot of heat, so it would take a lot of work to get the underside looking really mint. And there's some corrosion in the back too. This must have been a bit of wet storage at some point, because anywhere where there was flux, there's corrosion. And you know, we can really work to get that stuff out, but I don't think that's really what the scope of what we're doing here. One more and then I'll crank them down a little tighter once I double check. Okay, so while I'm waiting for a couple more caps to arrive, I'll tackle this cabinet a little bit. So we're gonna clean all in behind here, reapply some Type Bond 2 with a little bit of water dilution, spread it on, clamp it down so that it doesn't just keep peeling and get really bad. Same thing on this side. The bottom is probably okay. I might just touch this up a hair, but it's not as bad. And there's a couple little spots on the side where I might just apply a little glue, tape it down so it dries in place and is less likely to get snagged on something. I'm not going to go crazy. Probably won't touch up the front, although I probably should. Look at that, eh? Okay, yeah, I'll touch up the front corner where I can. And we'll also have a look at these RCAs. So the shield is ground, and as you can see, or maybe you can't, barely hanging by a thread. I'm surprised we get reverb all the time, but I'll see if I can just add some solder blobs to make that last a little longer. The other option is to just put some new ends on these, but they're expensive for some reason. That one's less bad. That one's pretty bad. Okay. Making the magic mixture. Alright, we're clamped in, glued in on this side. Looking good. Okay, I got the other side clamped in place now too. And we'll touch up on the bottom here, a couple touch-ups on the corner and the side too. So we'll let that dry and check it out.